Hi, this is Kelsey, your instructor for UNIV 1113, and this is a homework video on making good figures. Tufte basics for undergrads. Edward Tufte was, or maybe still is, a professor at Yale who teaches statistics and some data visualization type stuff and has really good rules on how to make good figures. So, three that are very important, I think, for undergrads are to tell the truth. Make sure your figures, tell the truth. Um, Maximize your data to ink ratio, which we'll talk about what that means in a minute. And then this third one, that simple graphs are better. So let's keep this example in mind as we're moving through this presentation. You measure twice as much oxygen in one sample of Martian atmosphere than another. Which is the best plot? So let's look at this first example over here. We've got oxygen and sample number, but we've got really dark lines. We've got no axes over here, just really, really dark black grid lines, and then two large points with different colors, but it's not clear what the colors mean. This is this idea of there being a lot of ink going on here, and very little of it is dedicated to the data. In the second example, we now have grade axes. They go from 0, 10, 20, and we can see our two samples. And yes, this sample is 10, this sample is 20, so 1 is twice as much. In this example, we've got 10 now at the bottom. We've got 20 at the top. So you can see it looks like there's this huge spread between this data. And it's not, clear how far down the scale goes. So even if somebody came over here and they were like, okay, well, this is 10, this is 20, so yeah, it's twice as much. Visually, this is kind of lying to you. So this is violating the tell the truth one. And then this over here is got the right scale again, but now we've got these vertical bars. And so it kind of seems like something is being tallied up over time. We're taking up more space. So this is kind of lowering the data to ink ratio, and it's not as simple as it could be. This is a great example of what you'd want your graph to look like. So first, tell the truth. So that means showing the whole scale bar, maintaining one scale throughout a graph or a series of graphs if you can, and then don't use more dimensions than what your data has. So let's look at this example. We've got oil prices that they're saying were stable for a while, but are rising again. And you've got so many different scales here. These are scales in years. These are scales in months. This is a scale where we've got dollars, like 2468, but now over here, we're jumping to 13, and suddenly it looks much higher than 12, when really it would probably plot about right here. These bars are actually really close together, but you'd never know it looking at how big they look. And it's also moved out in a third dimension. So I have a warning over here. Be wary in Excel of any plot that's going to give you a 3D bar graph. I hate these. They're horrible. They are not good. And they lie. And it makes you, makes the eye kind of exaggerate the data in a way that's not very truthful. The second thing is you want to max out your data to ink ratio. If it doesn't explain your data, okay, like all of these extra additional grid lines, this gray background, if it doesn't explain the data, get rid of it, okay? Use multiples if you can. So if you have a bunch of graphs that all have the same axes, put them next to each other and just use one axis across those graphs. So back in this first slide, if we had 4 plots and they all looked as good as this one, we could have stacked them up next to each other. We still would have had sample number across the bottom, but if the scale was the same and it was still oxygen on all these axes, we could just put it on this one on the right, and we wouldn't have to repeat that across each of those plots. Also, make the data the most important part of the figure. Here we've got color that's trying to unify different groups of things, but it's not really standing out because of this dark background. Over here, it's not a question about what's important. We can look at this right away. We still can see groupings, but the data itself and not the color red or the color blue is standing out as the most important thing. Oh, and just putting this out there, if it were me making this graph, I would have gotten rid of these lines and I would have gotten rid of this border because there's no reason to have that. Simple is better. There's two key things here. One, avoid chart junk, and two, use color carefully and purposefully. This is chart junk. Okay, this is a graphic about how many people or the percentage of people in different cities that commute to work. It is supposed to be some kind of a bar graph, but the scale isn't entirely clear. You don't have any idea how many people are included. It's pretty. I like the color scheme, but it takes so much to process something like this. This is not a good. This is not a good. This is junk. This is also junk. Look at that. That is not a histogram. Those are teeth. And it's supposed to give you the idea of some kind of monster, like the monstrous cost of what the Senate spends across these years. But really what you're focused on here is a monster, and it's not the numbers. So this is the better way of displaying that data. So avoid junk and pay attention to color. So I want to introduce you to this really cool tool called Color Brewer. So in Color Brewer, you just Google Color Brewer 2 or type in colorbrewer2.org. You can pick out the best color schemes for organizing your data. So you pick out the number of classes of data you have to display, say 4, and you can choose that it's either going to be sequential data, diverging data, so you want to show contrasts, or qualitative data, so descriptions, but let's just do sequential. We want it to be a gradient. You can pick multi-hue gradient, so these are all one color but with multiple hues. A single hue, which is exactly a single color, but here it really is just a true gradient difference. And you can also choose color schemes that are colorblind safe. And then this is really what I like. So hexagonal colors, these are the codes that you would use if you were writing computer code for color, which I really like. But you can also choose to display these as RBGs, which could be great for, say, doing this in PowerPoint or doing it in Adobe Illustrator and choosing these colors. So that's what I like. I use Color Brewer a lot, and I recommend it to anyone trying to pick good colors for posters or figures and trying to pick ones that don't lie. So anyway, thank you. That's the video.